Dear students, in this video I'll be discussing about the gated SR latch. In the last video we have discussed SR latch with the NAND and NOR. Now we'll be discussing gated SR latch with the NAND. So this content is an S bar and R bar. So we know the truth table for this. So S and R, if these are the values, S bar, R bar will be like this. So this is our Q bar. And what is the description? So now we'll look into this. What will happen with the effect of the gate? If the gate input is 0, okay? If the gate input is 0, what we are expecting here is S bar and R bar. So we'll consider one of the inputs, okay? If S is 0, suppose. If S is 0 and R is 1 and the gate is 0 now. 0, 0, the output here is 1. 0, 1, the output here is 1. So when S bar and R bar is 1, 1, what is the condition we are going to get? Previous state. But what is our S and R input? 0 and 1. When S is 0, R is 1, what we expect is reset, but we are getting previous state. Means when the gate is 0, so we'll be getting for any input of S and R, we'll be having previous state. So then when the gate has been 0, it is no change. So we'll just change this gate input to 1. If gate input is 1, with S and R is 0 and 1, what we are going to get? When S is 0, gate is 1, so your output is 1. When gate is 1 and R is 1, the output here is 0. So when S and R are 0, 1, so 0, 1 condition, our S bar is 1, R bar is 0. S bar is 1, R bar is 0. When this is the condition, we'll be getting reset. So 0, 1. We've already worked with what is the output of this SR latch with the NAND gates, and we just need to focus only on the effect of the gate here. So it's very clearly known now, when gate is 0, it is disabled, like our output will be previous state for any value of S and R. When gate is 1, whatever our S and R input, based on that we are going to get the output across the flip-flop, either set, reset and unchanged. So the forbidden condition, we know we cannot predict that. Okay. This is how the SR flip-flop with the gated SR latch. The working of the gated SR latch. This is the truth table. You need to write down the explanation part whenever you get this question in the exam. Next, we'll move on to the clock input. So instead of the gate, if I make this as a clock, how this works? Okay. Now, when the change is with respect to the gate, now while writing the truth table, what I mention here is the clock. So clock is the input, S and R input, and what is the output? Q bar. That is what we are going to write. So in the apply of the clock, I can mention like this, or the clock I'll just mention it like 1, 1, 1. The way how I have written it for the gated latch, G is 1. So based on our S and R input, I'm going to get the output accordingly. When G is 0, no change across the flip-flop. Similarly, when clock is 0, no change across the flip-flop. When clock is 1, we're going to get the output across the flip-flop. There is no change. The clock, either I'll be representing it as 1, 1 or as a clock input like a signal. I can write in any way. This is your clocked SR flip-flop. The earlier one is a latch. Now we call this as a flip-flop. The application of by applying the clock input. Now this clock, I just need not to provide the clock. I just need to make some changes with respect to the clock. I want to apply an edge triggered clock. What I do then is, instead of just applying a clock, I'll just make some alternative for this. Work only with the change in the events. So this is the clock. Just given here, Only with this event occurs, then you do the changes. The meaning here is only in the raising edge of the clock you do the changes. How I'm going to write that is, so if this is my clock input, earlier it was affecting for this entire high. Now with this change, it will be affecting only in the rising edge of the clock. Only is this particular instance of time. Based on the input, it will work with the output. If this my previous output was 0 till here there will be a change as 0 or 1. That is how it will work. Only with the change in clock event. Based on this, it is a positive edge trigger. Only at this particular instance of time, our output will have a change based on the S and R input. So here I'm not showing all those details. I'm just telling you how it will work with. What if it is a negative edge? You're going to write one bubble before this. That's it. So if this case, so it will be triggering only in the negative edge of the clock. Means when the clock is changing from 0 to 1 is a negative edge. 1 to 0 is a negative edge. 0 to 1 is a positive edge. This is how we can able to work out with the negative edge triggered SR flip-flop or positive edge triggered SR flip-flop. The truth table retains the same. I need not to show this S bar, R bar. This I've written only for your better understanding. So just write down what is your S and R and write down the clock. This can also be shown like an up arrow. The positive edge can also be shown as an up arrow. The negative edge can also be shown as an down arrow of the thing. So it indicates the negative edge of the clock. Sorry. We need to write down the timing diagram as well along with the circuit, truth table and timing diagram. This is the timing diagram of this SR flip-flop with a negative edge triggered clock. So negative edge trigger, whenever the clock changes from 1 to 0, there will be a change in the output. So that's why I've highlighted these points. So only in this particular time instance, it will change. So this is the clock, and I want to write all conditions of the S and R. So since 1 is forbidden, I have not written that. So 0, 0, 1, and I have written 0. R condition 0, 1, 0, 0. Now, what is the output of the Q? So Q we know when S and R is 0, 0, when S and R is 0, 0, previous state. So whatever was the previous state, I've written 1 here. At this particular instant, since S and R is 0, 0, it retains with the previous state until the next negative edge of the clock. Then here in the negative edge of the clock, 0, 1. 0, 1, it is reset. So 0, 1, it is reset. We get it 0. Then at the next negative edge of the clock, what is the S is 1, R is 0. 1, 0, it is set. Set, we get it 1. So here, with the next negative edge, S and R is 0, 0. So previous state. So we should be very careful. Only at the negative edge of the clock, there will be a change in the output. So Q bar reverse to this. So you can consider any state as a present state, like before we start with, and we need to write according to that. So with this, the working of the SR flip-flop with the negative edge trigger is done. Then we'll look into the D flip-flop negative edge trigger. So the basic building block for any flip-flop is an SR flip-flop or an SR latch, what I can say. So this is with a NAND latch, and we know how this SR will work. Now we'll convert this SR into D. The truth table of the D flip-flop is it is having only one input, the D. This is our Q. If D is 0, this is 0, D is 1, this is 1. So D flip-flop is also called as a delay flip-flop or a data flip-flop. Whatever the input I provide, I'll be getting the same output. So Q is a complementary output. Now in this video, I'll be discussing with the negative edge triggered D flip-flop. So what is the input basic building block? Here is an SR flip-flop. We are having an inverter across this S and R input. So when my D is 0, S is 0 and R is 1. So 0, 1 or 1, 0. So this SR flip-flop, we're working like set or reset, that's it. When D is 0, S is 0, then it is reset, so I'll be getting 0. When D1, S is 1, then it is set, I'll be getting 1. So now with the application of this negative edge of the clock, the flip-flop will be operated only across the negative edge of the clock. So when there is no clock, the output retains the previous state. So now I'll consider my D as 0. One more very important thing when we are working with the clock. So the input should be there before this event occurs. So that's the reason I make my input before that event. Even if you look into this point, before this event occurs, my D is 1. Before this event occurs, my D is 0. That is how you need to write. At same instance of time, D and clock changes, you can't get that effective output at the same instance. So you need to take care while writing the waveforms. With this event should occur before the so the value of the input should be there before the event occurs. Okay, D0 with the negative edge of the clock, our output is 0. Whatever our input, the output follows the input in case of D flip-flop. So earlier condition of the earlier my Q was 1. At this particular instance of time, my Q becomes 0. When Q becomes 0, Q bar is reversed to that is 1. So here it is 1. So here at this time instance, it has been changed to 1. Here it is 0. So it's been changed to 0. The Q bar is reverse of that. This is what the timing diagram of the D flip-flop. The truth table, what I have written here is for the latch. When I write it for the clock, just add on an additional year with the application. This is negative edge. You write down the down arrow. When the clock negative edge, the D0, Q0, D1, Q1. What if there is no clock? Then there is no clock. So I can write it as 0 when there is no clock. Okay, there is some issues here, so I can't write it. When there is no clock, irrespective of the D, it is previous state. So here it's a little difficult for me to write it. So when there is no clock, irrespective of the D, my Q is previous state. This is what the working of the D flip-flop with the negative edge trigger. Similarly, you can work with the D flip-flop with the positive edge trigger that changes only with respect to the positive edges of the clock, or else just clocked D flip-flop. So then that will be working at the level trigger. So at this particular instance of time, there will be a change, not at this event. Okay, that is how we can do it for the level triggered D flip-flop. Similarly, you can do it for level triggered SR flip-flop. So in the exam, it can be asked like clocked D flip-flop. Just write it the normal clocked D flip-flop. So at that particular instance of time, your output will be different. I'll just show that how it works. This is how it works. If it is a level triggered, in this particular instance of time, it operates. So here the D is 0. So I'll be getting 0 at that particular time. If my Q was 1 before, as soon as this particular instance of time, my Q becomes 0 since D is 0. Again here it is 1. So it has been changed at that instance to 1. And it has been ended there. So it continue with 1 only till the next clock arrives. So here again it is 1. So it continue with 1. So here in this clock event, so it's been 0. So it's been changed to 0. Now I'm not working with this level, like not working with the negative triggered now. So I'm just operating with the clock time. That is how it will work with. So with this, I'll wind up this video. Thank you.